So, unit circle. How many of you have seen a unit circle before?
I've heard of it. I've seen circles before.
Unit circle is just a circle which has a length of 1, sorry, a radius of 1 from the center to the outside.
Yeah.
So that means the x value for this, going from the center to the right, is equal to 1. So that's why this is 1, 0. On the top it's 0, 1. To the left it's negative 1, 0. And on the bottom it's 0, negative 1. Now, really quick thing. Have you guys ever seen quadrants before? Yeah, quadrants are top right. Then it goes 2, then 3, then 4. Any questions with that? Yes, it always goes anti-clockwise. Sorry, what? Yes, we'll come back to that later. Any questions? Okay, now, important thing to note. We can actually draw this out so that we can find how far away it's going, and we're going to label this with angles. So, if we're going around in rotation, starting from here, there is no angle, so that's 0 degrees, or 0 radians. What about the top? Some of you just did this, so you should know. 90 degrees, what is it in radians? It's half of 180, so it's going to be pi over 2. This one, 180 degrees, which is the same as pi. So the bottom will be 270 degrees. And what's that the same? Very good. You guys get the idea. Now, that means if you look on the first quadrant, it's between 0 and pi over 2. Second quadrant's between pi over 2 and pi. Third quadrant's between pi and 3 pi over 2. And then the fourth quadrant is 3 pi over 2 to 1 more, or 2 pi.
Yay.
Okay? Nothing too difficult. It's all literally just drawing one circle out and then you're just having a look. Maybe practice drawing like the freehand drawer. See how you go. Alright. So A. Give a trigonometric value using radian measurements of the point P that lies between 2 and 3. I've drawn a unit circle here just to help us. Where's quadrant 2 and 3? So is it, where do we start? Top right, yeah. So that's 1. What's this? 2, 3, 4. Give a trigonometric value using radian measurements of the point P that lies on the boundary between quadrants 2 and 3. What's in between 2 and 3? Right there. So that will be, it says radian measurements. So that's 180 degrees, which is also equal to pi. Good. Identify quadrants which will lie at 250. Where's 250? 1, 2, 3, or 4? 3. So there's 250. So 250 degrees in quadrant. That is not a D. 3. 400 degrees.
That is in quadrant 1. No. Well, 5?
Alright. There is a trick.
Is it 105? Is it 1?
That's 360, isn't it?
Yeah.
What do you have left? 40 degrees, so it just starts again to here.
1.
So it's in 1.
So 5.
And then 2 pi over 3. What do you think that's in? If you're not sure, best way to do it, see how that's a pi there?
Yeah.
Cut this into 3 parts. There to there.
3 to 4.
So is it going to be A, B, or C? You cut it in thirds, so how do we go 2/3? That's 1/3, then there's 2/3, so where are we at? And then negative pi over 6. Now, if this way is forwards, what's the negative? Backwards. So we go clockwise instead. So that way. Now, if we're going pi over 6, how far do we go? Is it past 90 or not? No. So it's somewhere here. So what quadrant are we in? Nice and simple, this section. And then C. Give two other points with a negative value, which would have the same position as a point 250 degrees. Okay, so why do you need... Okay, let's firstly work out 250 degrees. Where's 250 degrees? Quadrant 1, 2, 3, or 4? 3. Then, what do you need? I am confused. I'll have a look at it later, and I'll double check. I'll redo this one later. I'll add it on. Alright, then, important points that you need to know. If you have a look, you can make a right angle triangle with this. We set the length is always going to be 1. So if I write out cos, if I want to work out x, is that going to be cos or sine? Cos, which is x over 1, which is the same as x. In other words, cos theta is the same as x. So if we're doing sine, what's that the same as then? Y. So that's important to know. These values of p of x and y is also the same as p of cos theta and sine theta. What that means is if we have a unit circle, we can literally just tell what the values are of cos and sine just by looking at the x and y values. It's bizarre, isn't it? Then the tan one's a little bit weird. The tan one, you draw a tangent right at 0, which is this line, which is shown there. Then you would extend this triangle, and using similar triangles, you can work out tan theta. Or there is a much simpler way to work it out, which I will tell you in one moment. Right now. Tan theta, which I mentioned before, is a ratio of the triangle. If you have a look at the one before, you have sine theta over cos theta. Don't forget that. In other words, it's a ratio of x over y. Okay? Almost done. So, I've mentioned before that we can now work out the different parts using sine, cos, and tan using the unit circle. If we're at the start here and we set its x and y values, so this one is the y value, this one is the x value. What's the y value at 0? 0. Cos? 1. Because that's an x value, right? What's the x value at 90 degrees? 0. What's the sine value? 1. At 180 degrees, what's our x value? -1. Sine? 0. This one? Then all you have to do is just look at tan, which is 0, undefined, which is why it's undefined, 0, undefined. Alright, almost done. Calculate the coordinates of P, showing the position on the diagram. So let's show the position first. What quadrant is that in? 1, 2, 3, or 4? 1. Right there. And we know the angle is pi over 3. What's our x value again? Cos or sine? Cos. What's cos of pi over 3? If you don't remember yet, what's cos of 60 degrees? A half. What's our y value? 9. It's the other one. Come on, come on. Good. So there you go. A half root 3 over 2. Illustrate 130 degrees, and then, alright, I'm going to skip the calculator bit, but you can surely draw tan of 130 on there. What's tan of 130? What quadrant? 2. So then, yeah, I'm not entirely sure why it's telling you to use a calculator to work that out, but anyway. Okay, done.